There was a mathematician named Cartesian who first defined a point. He did it by drawing two lines perpendicular to each other on a plane. The point of intersection is called origin. He called the horizontal line as called x-axis, any perpendicular line as y-axis. Here we will confine our study graphs in connection with science. There are four parameters that define a motion: distance traveled s, time consumed t, therefore speed or velocity v, and acceleration a. All of the four parameters are interconnected to each other. In fact, one and the best way to understand as how are they connected in science is to draw graph between them and make conclusions. In physics, one should be able to interpret motion by looking at graphs. Basically, three kind of graph we shall try to interpret are distance time graph, velocity time graph, acceleration time graphs. Distance time graph. When a body moves, a distance is covered and time is consumed. Time is being an independent term, therefore always drawn on x-axis, and distance on y-axis. When equal distances are covered in equal interval of time, graph drawn will be a straight line, otherwise a curvilinear line. A uniform motion on a graph is represented by a straight line and non-uniform by a curve. The slope of a line on a graph indicate the direction and speed of motion. Larger the slope, larger the speed. And vice versa. Speed time graph. When a body moves, speed or velocity changes with time, either increases or decreases. Time being an independent term always drawn on x-axis, and speed or velocity on y-axis. When change in speed or velocity is same in equal interval of time, graph drawn will be a straight line, otherwise a curvilinear line. Straight line here correspond to a uniformly accelerated motion. And curved line to a non-uniform motion. Slope of the line in AVT graph correspond to acceleration. As slope equals perpendicular upon base or a equals v upon t. When we draw a graph between acceleration and time, we get a straight line, which shows rate of change in velocity with time is uniform acceleration. Area between acceleration and time gives us velocity. Here we have some questions now. On dt graph, what does the graph represent? Since equal distances are covered in equal interval of time, straight line represents uniform motion. In this figure, slope of line increasing therefore corresponds to acceleration. Here slope of line decreasing therefore corresponds to retardation, or one can say negative acceleration. Here since time taken is increasing but distance remains same, this means a position of rest, or a line parallel to x-axis represents constant distance. Here in the figure A, you can see equal distances are covered in equal interval of time, therefore graph corresponds to a uniform motion. See the figure B, the curve is ascending up, means gradual increment in motion per unit times. Therefore, graph corresponds to a non-uniform motion, or acceleration. In figure C, there is gradual decrement in motion, therefore correspond to retardation. In figure D, line parallel to x-axis show the position of rest, or constant distance. Here is another question. 4 cars A, B, C and D are moving on a leveled road. Their distance versus time graphs are shown. Choose the correct statement. A car A is faster than car D. B car B is the slowest. C car D is faster than car C. D car C is the slowest. Using the property in ADT graph increasing slope increases speed, we can say B is true. First graph shows a straight line corresponds to acceleration. Second straight line is sloped downward correspond to retardation. In the third, graph is discontinuous at 2 points is non-uniform acceleration. Fourth graph is parallel to x-axis means velocity remains constant with the increase in time, hence shows a zero acceleration. Draw a velocity versus time graph of a stone thrown vertically upwards and then coming downwards after attaining the maximum height. When a stone is thrown up, velocity decreases and comes to zero at time t, and then stone is under gravity and falls. Velocity is increased and then comes to its original position. Graph is like this. The displacement of a moving object in a given interval of time is 0. Would the distance traveled by the object also be 0? Justify your answer. Let a body move from a point A to a point B, then back to the same position A. In such cases, displacement will be 0. But distance is not. Simply because final position is same as initial position. Distance is always greater than or equal to displacement. How will the equations of motion for an object moving with a uniform velocity change? Since the object is moving with the uniform velocity, then v equals u plus at. But given that a equals 0, therefore v equals u, and s equals ut. A motorcyclist drives from A to B with a uniform speed of 30 km per hour, and returns back with a speed of 20 km per hour. Find its average speed. Let motorcyclist covers a distance d. Here is let the time taken is t. Speed is 30 km per hour. Therefore, t1 equals d upon 30. And similarly let the time taken during return is t2. Speed is 20 km per hour. Therefore, t2 equals d upon 20. Average speed equals total distance traveled upon total time taken, equal to d plus d upon 30 plus d upon 20, equal to 2d upon 50 d upon 600, equal to 1200 upon 50. And finally answer is equal to 24 km per hour. The velocity time graph shows the motion of a cyclist. Find I, its acceleration, E, its velocity in E, the distance covered by the cyclist in 15 seconds. When we see graph velocity is parallel to x-axis, means velocity is constant throughout, hence acceleration A equals 0. Velocity equals 20 meters, distance traveled in 15 s equals ut, equals 20 गुना 15 equals 300 meter.